All right, so we're going to be finishing up 10.3 today. I made the 10.3 homework due on Sunday. So 10.12 homework is due Friday at midnight, and this homework is due Sunday. And the purpose of that is just to make sure that you're doing it before the test. But if you have questions about it, I would recommend looking at it by Friday. So 10.3 is series. We talked about series, partial sums. Oh, so partial sums, there are questions about partial sums on the quiz, I believe. Then we wrote out terms of sequences and series. Then we talked about geometric series. And we said geometric series are of the form, the summation from n equals 1 to infinity of a times r to the n. So if we ever have numbers to the powers of n, that's when we know we have a geometric series. And here's the conditions for convergence and divergence. So we did some examples, and we said a lot of these are rewriting this to look like this form, right? That's basically what we need to do in order to tell if it converges or diverges. So number 4, we didn't have to rewrite it all. Number 5, we had to use some algebra. We recalled our rules of exponents in order to rewrite it and to determine a times r to the n minus 1. Okay, so let's go back and do number 6. So number 6 is the summation from n equals 1 to infinity of 2 to the 2n times 3 to the 1 minus n. So we need to make this look like the summation from n equals 1 to infinity of a times r to the n minus 1. Oh my goodness. So let's recall another rule of exponent. So here's one of our rules of exponents. Let's recall another. So recall x to the n to the m power is x to the n times n. So we multiply, right? Here's when we multiply. And the reason I'm bringing up is because I have this 2 to the 2 times n, right? So I need to rewrite this as a times r to the n minus 1. So this one's pretty close, right? But this one is not. So who can help me rewrite this using rules of exponents? So I have the summation from n equals 1 to infinity of 2 to the 2n times 3 to the n minus 1. You can see David's trying to squint to see it. I don't know, can you see that you can choose speaker view, David? Okay. Okay, so who can help me? Okay, let me get it started. Summation from n equals 1 to infinity. 2 to the 2n, I'm going to rewrite like this, because really what I want to see based on this is powers of n, right? This 2 times n, that's not helpful. So this is 2 to the 2 times n times 3 to the, what can I do about this? 1 minus n, I want it to be n minus 1. What if I factor out a negative 1 from that? That would be helpful. Right, because if I multiply these two, which is my rules of exponents that I wrote out here, if I multiply these two, negative 1 times n minus 1 is 1 minus n. Okay, that looks good. All right, so this n minus 1 I want, but this 2 to the 2 squared is 4. This 4 to the n, I need to make that 4 to the n minus 1, right? So I have 4 times 4 to the n minus 1, and here I add these exponents, right? Was this too fast, or is this okay? 2 squared is 4. So I'm saying n minus 1 plus 1 is n, right? I add these exponents to get that. And then here I have 1 over 3 to the n minus 1, right? The negative exponent, I bring that down to the denominator. All right, so let me put this all together. I have 4. I'm going to put these two together because this is going to be my r. This is 4 over 3 to the n minus 1. Now this looks like the summation from n equals 1 to infinity of a times r to the n minus 1. So all this stuff I did here was rules of exponents. And it's these two rules that I wrote out, right? It's these two rules that I wrote out. So let me walk through it again. Here, I did 2 to the 2n is 2 squared to the n, right? And then by this rule, 2 squared is 4. So I could have written this as 4 to the n. But I want it as 4 to the n minus 1. So if I rewrite it as 4 to the n minus 1, then what do I need to put here to make this equal, right? Blank plus n minus 1 equals n. Well, this has to be to the 1. And then here, I factored out for the 3, I factored out a -1, and that made this n minus 1. So I just rewrote a negative exponent goes down to the denominator. And so now I have numbers, and then I have numbers to the n minus 1 power. So I can combine my a's and I can combine my r's. So this is my a, and these are my r's. Okay, so I'm gonna get my white out so I have a little more space to write. Okay, so for the geometric series, a equals 4. A is just the number, and r equals 4 over 3, right? R is to the n minus 1 power. So the absolute value of r, now I'm checking for convergence. The absolute value of r equals the absolute value of 4 over 3, which equals 4 over 3, which is greater than or equal to 1. So from my statement up above, it diverges. So the series diverges. I'm writing so a lot, let's say therefore. So therefore the series diverges. Good. So a lot of these are just rules of exponents, right? All right, let's talk about the next type of series, which is a telescoping series. So when you think about a telescope, I always picture when you think about a telescope, you think about expanding something out so you can look at it and then contracting it back down, right? Kind of what a telescope, I kind of think of with a telescope. So that's what we're gonna do. We're gonna expand out the telescoping series, take a look at it, and then try to contract it down as much as possible. Okay? So telescoping series is typically of the form fraction minus a fraction. Typically they have the same numerator and the denominator contains n. So that's how we can tell when we're looking at a telescoping series. All right, example, determine if the following series converge or diverge. If they converge, determine what they converge to, okay? So looking at this, I have the summation from n equals 2 to infinity of 3 over n minus 1 minus 3 over n plus 1. So this is a telescoping series. I have a fraction minus another fraction. The numerator is the same and the denominator is different. So what I want to do is I want to write it out. I want to expand it out, write it out, and then try to contract it down and see what happens. All right, so let's write it. So I'm going to label everything. Here I have n equals 2, right? I'm starting when n equals 2, and let's plug in n equals 2 to see what I get. 3 over 2 minus 1 is 1, minus 3 over 2 plus 1 is 3. So that's my n equals 2 term of this series. And then I'm adding, right? The summation means addition. And then I'm going to write when n equals 3. All right, when n equals 3, I have 3 over. N equals 3. 3 minus 1 is 2. Minus 3 over. N equals 3. This is 4. Plus, all right, you guys write out a couple terms. I know this is something you guys can do on your own. All right, so I did to n equals 6. And then let's see if we can identify anything. What do you guys see that happens? So we expanded it out. We need to take a look at it. Look, I have negative 3 over 3 plus 3 over 3. That equals 0. Oh, I have negative 3 over 5 right here. And I have positive 3 over 5 right here. That equals 0. Let me get another color. Okay, negative 3 over 4 right here plus 3 over 4. That equals 0. Let me write out another term. N equals 7. Let's see what we have. We have 3 over 6 minus 3 over 8. Let's see what else cancels. Oh, here I have this 3 over 6, negative 3 over 6. That cancels. So what do you guys think is going to keep happening? If I write down the next term, what's going to happen? I think that
cancel.
This one will cancel, right? If I write down the next term, this one will cancel, right? So I think after, if I keep writing, I'm going to just keep crossing these out. So I've expanded it out. I've taken a look at it. And what am I left with? I'm left with this, right? Because everything after this cancels. So I'm left with this, right? Do you guys see that? Okay, so I'm left with 3 plus 3 over 2, which equals what? This is 6 over 2, so 6 over 2 plus 3 over 2, 9 over 2, so it converges. Good. So here's the thing. We expanded it out. We wrote out a bunch of the terms. We looked at it, see what crosses out, and then we contracted it down, and this is what we're left with. Because once we can cross out one set of n, we cross out both terms in that set of n, then everything after that's going to cancel as well. You have a question, Kevin?
Yeah, so if you mess with it algebraically and put those two fractions into one fraction, you get 6 over n squared minus 1. Is there anything we can see from that just by doing it algebraic?
6 over n squared minus 1? What do you mean?
So if you multiply the first term by n plus 1 over n plus 1, and the second term by n minus 1 over n minus 1, that's what you get.
So if you can see from a question like number 9, we're going to have something where it's one fraction. From this, we're going to have to do partial fractions to write it as the summation, the addition or subtraction of two fractions. So we don't want it as one fraction. We want it as two fractions so we can write it out so we can see what cancels. Does that answer your question?
Yeah.
Okay. Not to spoil the exciting number 9 though. Okay, so once we can cross out one whole set of n, right? When n equals 4, I was able to cross out both terms. Then everything after that's going to cancel. All right, so let's do number 8. All right. Why don't you guys try to write it out? How many terms do you want to do? All right, I'll write it out. 2, n equals 2. So I wrote out 6 terms to an n equals 7. Let's see if I can get everything to cancel in one of these terms. So I have 1 over 6 minus 1 over 6, 1 over 8, 1 over 5 minus 1 over 5, 1 over 4 minus 1 over 4. I don't quite have a whole term canceling yet, right? So I have to write out a couple more terms. All right, let's keep looking. 1 over 8, 1 over 8 cancels. 1 over 7, 1 over 7 cancels. All right, so see here, I've gotten this whole term cancels, this whole term cancels, right? So once I get a whole term cancels, all subsequent terms will cancel as you continue to write out the terms, right? So when n equals 5, I got that whole term cancels, which means I'm left with this. So this equals 1 plus 1/2 plus 1/3, which equals 6 over 6 plus 3 over 6 plus 2 over 6, which equals 11 over 6. So it converges. Does that make sense? All right, so telescoping series typically looks like a fraction minus another fraction with the same numerator. See how the same numerator is super handy here? Right, different numerators, you could be writing it all day. All right, so let's keep cruising and do number 9. So number 9, the summation from n equals 5 to infinity of 3 over n squared minus n minus 12 doesn't initially look like a telescoping series, right? But like I said before, in order to make it look like a fraction plus another fraction, I can do partial fractions. All right, partial fractions. Oh my gosh, who can remind me? I have to factor the denominator. I get n minus 4 times n plus 3. Who can help me? Who can remind me what partial fractions? How do I do that?
A over the first denominator plus B over the second denominator.
Good. And then What do I do?
That equals 3. So you can cross multiply and get
Ooh, I don't like cross
an plus.
multiply. Cross multiply is when you have a fraction equals another fraction.
Right, that was the wrong word. You're going to get n plus 3 plus b n minus 4 equals 3.
Okay, so what you did was you multiplied by the least common denominator. Good. All right, and then what do we do? So now we choose values for n to cancel out stuff, right? So why don't you guys do partial fractions and let me know what you get. You guys done? What'd you get, David? I can't hear you.
I'm not quite finished yet. But
Okay. Okay, I got A equals 3 over 7 and B equals negative 3 over 7. Is that what you guys got? Good. All right, so now we can write this out. We can rewrite the summation, right? Because in order for it to be a telescoping series, we're hoping for a fraction minus a fraction with the same numerator. And I'm going to take that negative from B and make it subtraction, right? So it's a fraction minus another fraction with the same numerator.
Would it be plus 3 divided by 7 divided by h plus 3?
Where am I looking?
The 3 divided by 7 divided by n plus 3, would that be, you would add that, wouldn't you? Because
So
the
it's
b,
add. Go ahead, I'm sorry.
sorry, I thought it was a subtraction. Never mind. Okay.
So it's you're adding them, but I got this negative sign from B, and so then
Right,
I just made it subtraction.
I thought it was flipped. I thought that sorry, I messed up.
No, don't worry. Okay, so now I can see though clearly it's a telescoping series, right? I have a fraction minus another fraction, and they happen to have the same numerator. So now I need to write out my terms, right? So everybody go ahead and write out your terms. For this one, we need to write a lot of terms. N equals 5. So write small. All right, so I wrote out to when n equals 14. So now I'm going to go through and I'm going to see what cancels. Are you guys all good with that?
How far does it need to be written out?
So we need to write it out until we see that one full set of n cancels, right? Once we get one full set of n to cancel, then the rest of them will cancel. So I just wrote out a bunch to see when I can get things to cancel.
Okay.
So 3 over 7, or so over 7, I'm not seeing. Over 8, now I have that cancel, right? When n equals 5 and when n equals 12, I have something cancel. Now here I have this cancel. Now here I have this cancel. So shall we write more? N equals 15, n equals 16, n equals 17. Let's see how that goes. Over 11, that cancels. Over 12, that cancels. Okay, I'm running out of space. Okay, over 13, that cancels. Over 14, that cancels.
Is it going to stop at n equals 12?
How do you know that?
Well, on the left side, you're just increasing by 1. So your next term at n equals 19 is going to give you 3 over 7 over 15.
Yes. So I need to do one more. So plus 3 over 7 over 15 minus 3 over 7 over 22. And then you get there and you see 3 over 7 over 15, 3 over 7 over 15. Okay, so I finally got it to cancel. I finally got n equals 12. That whole term cancels. So all the subsequent terms will cancel, right? The whole n equals 12 cancels, so the rest of them will cancel. So now I need to write down, let me write what I have over here on a separate piece of paper. I think I'm gonna need a little more space. Number 10. All right. So I got this whole term to cancel, so all the subsequent terms will cancel. So now let me summarize, rewrite what I have, right? So then this equals 3 over 7 over 1 plus 3 over 7 over 2 plus 3 over 7 over 3 plus 3 over 7 over 4 plus 3 over 7 over 5 plus 3 over 7 over 6 plus 3 over 7 over 7. So what does that equal? I did it in my calculator and I got 1089 over 980. That equals a number, so it converges. Okay, whew, that was ugly. So let's try to get smart about this, right? We're writing out, and we just wrote out a whole piece of paper of adding up some fractions, right? So let's look at number 7. I ended up that the third term canceled, right? The third term I had to write out canceled. What's the difference between the denominators? the difference between the denominators is 2, right? And the third term canceled, okay? Here I had to write out 3. And then the fourth term canceled. The difference between the denominators is 3, right? So the difference between the denominators here is 3 and the fourth term canceled. The difference between the denominators here is 2 and the third term canceled. This one, super ugly. The difference between the denominators is 7. 1, 2, 3, 4, 5, 6, 7, and the eighth term canceled. So half of it is recognizing a pattern, right? Half the battle is recognizing pattern. I see the difference between it is 7, so I have to write out 7 terms. The eighth one will cancel. But you have to do a little more to see what you're crossing out, right? If you write out the eighth term and you see that you're crossing out the first one, then the first one for the rest of them should be crossed out, and then that eighth term will cancel. So really, once we catch the pattern, we don't have to write down all of this, right? If we're smart about it. So let me just say that again. So in number 7, the difference between the denominator n minus 1 and plus 1 is 2. The third term fully canceled. I didn't need to write down the rest of the stuff, but I need to see what cancels from those first 2 terms, right? All right, number 8, the difference between the denominators is 3. The fourth term canceled. So I have to write out the fourth term to see which part is canceling in order to know that I crossed out the second thing here. So the second thing is going to get crossed out every time. So do you guys see the pattern? Feeling good? All right, I think I keep dropping papers. Okay. So let's do this last one, number 10, so we can just be finished. Number 10, the series defined by 9 minus 9 over 5 plus 9 over 25 minus 9 over 125. So I'm trying to figure out if the series converges or diverges and what it converges to. What the heck kind of series is this? Kevin?
It looks like 9 over 5n squared from 1 to infinity.
Okay, so it looks like the summation from n equals 1 to infinity of 5. What did you say?
9 over 5n squared.
So 9 times 1 over 5 to the... You're really close. You got it, Kevin. I just want to make it look a certain way. Okay, so let's see. This is, the 9 is staying consistent, right? The 9 is consistent. This is divided by 5 to the what power?
0.
0. So this is n equals 1. N equals 2. This is 5 to the first. N equals 3. This is 5 to the second. So this should be 1 over 5 to the n minus 1, right? I forgot a little something though, right? Positive, negative, positive, negative. So how do I take that into account?
You have to multiply that by -1 raised to the n plus 1.
We could just put it in here, right? We can make it -1 over 5. Because if n equals 1, if n equals 1, this needs to be positive. So -1 to the n. Oh no.
I think the way you had it would work.
Yeah, yeah.
Is 0.
Yep, thank you. Okay, so we wrote out, so this is n equals 1, n equals 2, n equals 3, n equals 4. This is a series because I'm adding up a sequence, right? I have to look and try to be able to describe it. This was one of the first things we did in either this section or 10.1 and 10.2 where we we wrote out the terms. We tried to write the direct relationship. And here we wrote the direct relationship. And now what kind of a series is this?
Geometric.
Awesome. This is geometric. A times r to the n minus 1. So this is geometric. The absolute value of r is 1/5, which is less than 1, so it converges. So I've already kept you guys 4 minutes late. I'll write that out for this one and make sure I scan it and upload it. But if you guys have questions, stick around. If not, I know some people have other classes. But if you have questions, stick around, let me know. Definitely take a look at that quiz. That quiz is due before next class. Again, do the MyLab section and then submit your free response portion in with the Canvas portion of the exam, of the quiz, sorry. So if you guys have questions, stick around. If not, I will see you guys on Friday.
Thank you.
Hey, hi. So I wanted to ask, I'm trying to calculate my GPA through Excel, and I was wondering if you could help me out with that. Like, I don't know. Okay. Because I was trying to calculate, and for some reason, I don't know if I'm not throwing in the participation grade or whatever, but like it's not coming up.
Oh, for my class?
Well, like I'm trying to do it for every class right now, but for some reason, like no matter which class I do it, I'm still coming.
Oh, let me stop recording. Sorry.
Oh.